Good morning, dear students. Jai Shri Gurudev. Good morning, dear students. As the students, we can see so many changes in our everyday life. Those changes we need to know and classify those changes as physical and chemical changes. Let's take an example to study about these chemical and physical changes. You know what are those changes? Yes, cooking of food, melting of iron, boiling of water, rusting of iron, burning of candle. These are all the examples of changes. See, let's discuss these changes as physical and chemical changes. Yes, first one, cooking of food. Next, melting of ice, rusting of iron, then ripening of fruits, next boiling of water, next burning of candle. These are all the examples of changes. Now we need to know out of these changes which is physical and which is chemical changes. Let's discuss about these changes. The first one is cooking of food. If we cook a food, we can get a new substance in it. So it is an example of chemical change. Whereas second one is melting of ice. See, melting of ice, if you melt the ice, it changes to water. If you freeze your water, it turns back to ice. So it's an example of physical change because it is reversible. Ice turns to water, whereas if you freeze your water, again it comes back to its original position, that is ice. So it is physical because it is reversible changes. Whereas cooking of food is a chemical change. Why? Because it doesn't come back to its original position. It is irreversible change. So that's why we call it as chemical change. Whereas melting of ice is a physical change. Next, rusting of iron. So, you know what is rusting of iron? A brown color extra coating will be formed on the iron when it is exposed to air or moisture. So, if the brown color layer is called as rusting of iron, it is an example of chemical changes because here the rust is a new substance. That's why rusting of iron we call it as chemical change. Next one is ripening of fruit. So the fruit turns to seedling, from seedling to ripening. So it is a totally example of chemical change. So it is an example of chemical change. It doesn't turn back to its original position. If a fruit ripes, it doesn't come back to its original position. So that's why it is an irreversible change. It's called as chemical change. Whereas boiling of water. So the boiling of water is also a physical change because if you boil the water, it turns to water vapors. If you condense the water vapors, it gets back to its original position, that is what? Water. So it is a reversible change. The reversible change is an example of physical change. Next, last one is burning of candle. Dear students, do you know the burning of candle is what type of changes is it? Anybody? Yes, it indicates both physical and chemical change. Physical and chemical change. You know why? Because if you burn the candle, it produces wax. It is a physical change. But it melts, ignite metal, so So it melts means it produces carbon dioxide and water vapors. So the carbon dioxide and water vapors, it is called as new substance. So for this process, the burning of candle, it is called as both physical and chemical changes. So out of these changes, we finally conclude a type of, see, if physical change, if you represent a physical change, means it is reversible change and it is temporary change. Physical change is reversible and permanent. Sorry, temporary. Whereas a chemical change is irreversible and permanent change. So these are the differences between physical and chemical changes. Now let's discuss about a chemical change. See, chemical change. If a chemical change takes place means a chemical reaction has taken place. Chemical change is directly proportional to chemical reaction. Yes, dear students, today in our class, let's discuss about a chemical reaction. Chemical reactions and its equations. And equations. So, if a chemical change takes place means chemical reaction is taken place already. So, these two are directly perpendicular. So, now let's discuss about a chemical reaction. You know what is chemical reaction? Chemical reaction means the process in which new substance with the new properties are formed. The process in which the new substance and new properties are formed. It is a process. Chemical reaction is a process in which new substance along with it new properties. New substance and the new properties are formed means for this process we call it as chemical reaction. You know what are the examples of chemical reaction? Let's discuss about the chemical reaction with an example. So first, when an hydrogen combines with oxygen to give water. If an hydrogen combines with oxygen, it gives water. It is an example of chemical reaction because here it's see how we can define it's a chemical reaction. See here hydrogen is a gas whereas oxygen is a gas. Here the both are the gases. When these two elements are combined to form water, it is a liquid. Two gases combine to form a liquid. Understood? See, it is an example of chemical reaction. You know how? You know why? See, here water is a new substance here. Water is a new substance whereas water forms with the new properties. You know how new properties? Because these two are gases and this is a liquid. So these properties have been changed in the product side. So it is what? An example of chemical reaction. Let us take another example, that is sodium combines with a poisonous gas, that is what? Chlorine. Sodium combines with chlorine, it gives sodium chloride. So it is another example. So here sodium is a metal. First we should know sodium is a metal, it combines with chlorine. Sodium is a metal means it is a solid in state. Chlorine is a gaseous. See, almost all the metals are combines. See, here solid, gas, it forms salt. Sodium chloride is a salt. See, sodium combines with chlorine, metal combines with gas to give salt. That is what sodium chloride. Sodium chloride is a salt that we are using in our daily life in the cooking purpose. So it gives taste of food also. So these are all the examples of chemical reaction. Understood? Now let's discuss about chemical equation. Chemical equation. So, how can we define a chemical equation? A chemical equation means it is a symbolic representation of chemical reaction. Symbolic representation of chemical reaction. See, the chemical reaction is actually called as, another name of chemical reaction is word equation, whereas the actual name of chemical equation is what? Symbols in equation. So now we should learn how can we write a word equation to chemical equation. Word equation to chemical equation. So let's take an example of chemical reaction. First one is hydrogen combines with oxygen to give what? It is an example of which one? Chemical reaction. Let's write this word equation to chemical equation. So how can we turn this? So before we are going to express this in, see, first we should know the symbols or elements, symbols. So hydrogen, you know what is the symbol of hydrogen? Chemical symbol of hydrogen is H. Whereas the oxygen is O. You know, it's right. It is right where? No. See, each and every element of chemical equations should be writing molecule. So, elements, the rules of writing chemical equations is elements, it is using atomicity property, whereas compounds, if we write the compounds, we should use the rule, that is what? Valency. These two are the rules we should follow while we are writing those chemical reactions in chemical equations. Now, hydrogen. Hydrogen is in atomicity of hydrogen is molecule, that is what? H2. Almost all the gases we should write a molecule like 2. Two atoms of hydrogen are there here. Whereas oxygen is also a gas. The atomicity of oxygen is O2. So O2 molecule now. So when the hydrogen combines with oxygen, H2 plus O2 gives H2 combines with O2. It gives water. So water is a word equation. So here water. It is a one molecule of water we got. So this is the way of writing. The water molecular formula is H2O. Hydrogen combines with oxygen, it gives water or H2O. So this is what the way of writing word equation to chemical equation. Now let's take another example. Let's take another example. Sodium combines with poisonous gas called chlorine. It gives sodium chloride. So it is another example or the way of writing chemical word equation to chemical equation. So the symbol of sodium is Na. See, here sodium is a metal. Sodium is a metal means we should not write this metal as a molecule. It will be there in only one atom. Metals are almost writing in a one atom, that is no atomicity in a sodium atom. So Na plus chlorine is a gas. So we should write this in a molecule form. So Cl2. Na plus Cl2 gives sodium chloride, means NaCl. You know how I wrote this? Because here sodium and chlorine, the valency of sodium is 1, whereas the valency of chlorine is 1. If you crisscross this, Na1Cl1 means NaCl, whereas the first example we wrote now, so that is what H2O. You know how it forms on the basis of valency? Because it is a compound. The compounds are wrote in the basis of valency. Know how this wrote? So the H2O means the valency of hydrogen and oxygen is, the hydrogen valency is 1, oxygen valency is 2. If you crisscross this, we get H2O. H2O. So this is the way of writing chemical equation from chemical word equation. So this is what. So for writing chemical equation, we should follow two rules. That is what? One is atomicity for elements, whereas another one is valency for compounds. So these two rules we have to follow while we are writing word equation to chemical equation. Understood? As dear students, our next class, let's discuss our next period, discuss about balancing chemical equation. Thank you.